right, good morning, everybody. We're starting a new unit today, and we're going to be talking about expressions, okay? How to simplify, factor, and doing some other things with them, okay? So we're going to start out with simplifying expressions. There are a few things we need to talk about first before we get into this. Okay, and as you can see, I've already filled in some of the blanks at the top of the page. So an expression is a mathematical phrase that can contain variables, numbers, okay, and when we're talking about numbers, we're going to kind of we're going to call them constants, okay, and operations. So it says use the expression below to label the various parts of the expression. So we have negative 6x plus 12. Okay, well, let's just begin with the simplest one, really. All right, the addition. Well, addition is the operation. Okay, so we have addition, subtraction, multiplication, division. Okay. All right, so the next thing we need to understand is this side of the operation. We have negative 6x. This is called a term. Okay, and a little bit later, you can kind of see down here it's like, and unlike. Okay, so you have like terms and unlike terms, and we'll talk about those later. But this is a term, can be a number and a variable, which this is. It can just be the variable, or it can be just the constant or the number. Okay, so this is one term, this is two terms. So there's two terms in this expression. Okay, all right, now let's look. We're on this side of the operation, so if we have a number, and I've mentioned this in prior videos, okay, but we're really going to put it to use now. A number and a variable. So when they're right next to each other, we are multiplying those. Okay, so I'm just putting a little dot in between them. That's multiplication. All right. Now we don't know the value for x, so we can't multiply those. So like when we did our proportions, when we cross multiplied, whatever we multiplied the number and the variable, we just combined them like this right here. Okay, but the number that is with the variable, okay, so this negative 6, this is called a coefficient. Okay, and I've told you this before, that this is the coefficient and that's the variable. Okay, so I've already said this is the variable. Now this is called a variable because depending on what situation we're talking about, we can plug different numbers in for this x so that it varies. The value of x can vary, okay? So that's why it is called a variable. So the only thing we have left now, so we got everything labeled on this side, so let's move to the other side. We have 12, okay? And 12, well, it's a number, and we call that what? A constant. Okay, that 12 stays the same. All right, we have to add or subtract for that to change, so that's why it is called a constant. That 12 is always going to stay constant. Okay, so we have a coefficient, we have a variable, I have an operation, and we have a constant. All right. Now, you're not always going to have a constant. Okay, it could just be coefficients and variables all the way through, and we'll see that probably on tomorrow's assignment. Okay, so just a quick review: the number that is with the variable, negative 6, that is called a coefficient. The letter, okay, the variable is right here. This is called a term. This is also called a term, okay? This is your term. There's two terms in this expression. Your operation can be either addition, subtraction, multiplication, all right, and what's another way we can write multiplication is that little dot, okay, or division, okay. Now let's go down here to simplifying expressions, okay. The terms can be classified as, and like I was telling you earlier, like or unlike terms. Okay, like or unlike. And expressions can be simplified by combining like terms. Side note, if I can spell, only like terms can be combined. Alright, so if they're not like terms, you can't combine them, right? Because we can't take negative 6x plus 12. Well, why? Because we don't know what x is, so these are not the same term. We can't combine them. Alright, like terms must have the same variable and base. Okay, so we're talking about variables, and later on we'll see this. If this was to have plus, I don't know, 4x, well, this term is the same as this. Why? I'm not worried about the coefficients in front. I'm worried about the variables. All right, they have the same variable. I can combine those. Okay. I can combine my constants. Okay, so if it had, let's just say it had plus 1 out here. So I can combine these two, and I can combine these two. Okay. Example of like terms, 7x and 9x. So just like I told you, the variables are the same. 4d and 4g are not like terms. Okay. We have a variable of the d and we have a variable of g. Okay. You cannot combine d and g. Okay. Okay, so I'm going to do a couple of I'm going to do a couple examples, and I'll explain what the assignment's going to look like for later today. In the table at the left, so the left side, this one, which terms are like terms? So out of what the examples are given, we're going to determine which one of these are like terms. Okay, and we'll write the like terms over here. In the table at the right, this one, we're going to determine if they are like or unlike. Okay, so it's going to give us, well, it looks like 2 to 3 terms, and it's going to ask us if they are like terms or unlike terms. So right now we're looking for like terms. Okay, so let's talk about our terms. We have 8c, 16, negative 8c, and negative 16b. So if we're looking for like terms, okay, we either have to find variables that are the same, constants that are the same. Okay, so there's only one constant, okay, because these other ones have variables with them. So there's no other like terms, no other constants, so we can't use that one. Okay, so let's look at this one. We have 8c. Well, do we have another coefficient and variable c? Yes, right here. Okay, negative 8c. Like I told you up here, it does not matter about the coefficient in the front. If they have the same variable, they are like terms. Okay, so the like term in this case is negative 8c and 8c. Okay. All right, let's look at the second one. We have 12, negative 12x, and 12x. Okay, now these have a coefficient of 12. This one's negative 12, and this one's 12. And then we have a constant of 12. All right, just because you see all 12s doesn't necessarily mean that they are like terms. All right, we got to look at what is with those 12s. Okay, so we have a constant here because that's just a number and it doesn't have any variables with it. So that's a constant. This number has a variable. This number has a variable. Okay, so let's look at what the variables are. We have an x, negative 12x, and 12x. Okay, we can combine those. Those are like terms because the variable is the same. So we have a negative 12x and 12x. Okay. All right, let's look at the next one. We have 9y, 5z, 9w. Okay. Remember, it does not matter what the coefficients are. Okay. If we're dealing with a term that has a coefficient of variable, we want to pay attention to the variable. Okay. So we have 9y. Do we have any other y's? No. Okay. So there's no like term that will match this one. All right, let's look at the middle one. 5z. All right, so let's look at this. Is there any other z? No. All right, so there's no like terms for that. The last one is 9w. Okay. Oh, there's a 9. The coefficients are the same. Well, what did I tell you to look at? The variables. So do any of those variables match in those terms? No. So there are no like terms. Okay, so no like terms in this one. All right, let's look at the next example. We have 11g, 11, negative 7g. Okay, so we'll just take, we'll look at the first term. We have 11g. This is the term. We have 11. Will that match? Is this a like term as this? No. Why? Because the variable. Okay, we want to look for things that have the same variable. Okay. So what has the same variable as 11g? Well, negative 7g. So we have 11g, negative 7g. Okay. So let's look at the next one. I think for the most part we're getting the hang of this. Okay. So 0.5t, 1.5t. Well, I know those are like terms, right? Because why? They both have a t. Now, is it possible? I don't know why I put that dot up there. 1.5t. No variable with this constant, so these are the only two like terms. Now, is it possible to have more than two terms? Yeah, it is. Is it possible to have different sets of like terms? Yes, and I'll show you what I'm talking about later. Okay, so the next one, we have 1m, n, m, and 1. Well, that's 1m. That's a coefficient and a variable, m. Is there another m? Yep, right there. All right, so let's keep looking just to make sure. All right, so n, does that match those? No. Let's look at the 1. 1. Well, it doesn't have a variable with it, so that is a constant. There's no other constants there. Okay, so our like term is 1m and m. Now, 1 times anything is its what? Is what? Itself. So 1m and m, it's the same thing. Okay, because you're just timesing m by 1, well, that's still just m. All right, let's look at the next one. We have 4b, b, 7, and 9b. Well, there's a b with a coefficient. There's a b. There's a b. Well, I just asked, can you have more than just 2? Well, here you go. You got 4b, b, and 9b. Okay. 7 is a constant. No variables with it. Okay. All right, let's look at this next one. 0, -8, 13r. Well, there's no other r's, so that's not going to have a like term. The like term between these, what are these called again? Constants. So in this case, our constants are our like terms. Okay. Now, I asked you earlier about having, or can there be more than one set of like terms? So if we have all right, so we got 4x, 3t, x, and 5t. Well, x and 4x are like terms because they're the same variable, and we just bring our coefficient with it. All right, so there's one set. I want to set that off, so I'll put parentheses around it. Okay, then I'll make parentheses, and I got 3t and 5t. Well, they're both coefficients with the same variable, so 3t, and I was going to make another 3, 5t. Okay, so you just kind of split those apart, put parentheses around them. This is one set of like terms. This is another set of like terms. Okay. All right, let's get into, are they like terms or not like terms? Okay. All right, so 29 squared. Okay. Well, do I definitively know what 29 is? Yeah, it's 29. Okay. Do I definitively know what 29 squared is? Yeah, 29 times 29. Okay. So these are both constants. Okay, because I know what this one is. I know what this one's always going to be. Okay, so they are like terms. They're constants. All right, let's look. We got b and 3b. Are those like terms or unlike terms? Well, they both have a b, right? And this is the coefficient with this b. But even though this one has a coefficient, this one doesn't, well, I can combine these two terms because they're both b. Okay? So that means that they are like. All right? 6 and 9, they're both numbers, right? Which we call numbers now constants. So those are like terms. All right, we have -3r and -3p. All right, a lot of you are going to look at just, well, both of them have -3, so that's right. No, we got to look at the variables. Look at the variable. If the variables are different, they're not like terms. We can't combine them. So unlike terms. Okay, 13k and 13k squared. Okay, now I know up here we said square because we know what this is going to be. Do we know what the value of k is going to be and k squared? Okay, no, we don't. Okay, because if k can vary, well, guess what? k squared is going to vary as well. All right, so that's an unlike term. Well, if I can spell like. Okay, so anytime you have an exponent with your variables, okay, then it's going to be an unlike term. Now, if this one was 4 or C4, and this one is C4, then those would be like. But seeing this has a different exponent than this, then we are unlike terms. Okay. So I'm just going to stop right there because I'm about out of time. So for your assignment, you're going to be given expressions, and you're going to be asked about, well, what are the like terms? Okay. Are these terms like or unlike terms? Okay. I'll put more explanation in the description to help you out, because I'm fixing to be right up on the end here. Okay. So both of these are like terms. Okay, down here. These are constants. All of these have a C. So pay attention to if it has an exponent. If they have the same exponent, they're like. If they have different exponents, they will be different. Okay, unless you're talking about constants. It'll be just a short assignment for today, and then we'll get into actually simplifying expressions Thursday. Okay, have a good day.